that we have two resistors that are in series, and the equivalent resistance of these two resistors is 690 ohms. So basically, what they say here, well, they say we have two resistors connected in series. We don't know the resistance, but we know that the equivalent resistance of these two resistors is going to be 690 ohms. Now, in the second part of the problem, they say when they are connected now in parallel, the equivalent resistance is 150 ohms. So basically what they say is, now if I get the same two resistors and I just get and connect those resistors R1 and R2 in parallel, remember we don't know the values of R1 and R2, then now we can substitute then by an equivalent resistor with 150 ohms. So the resistance equivalent in parallel would be 150 ohms. So they say find the resistance of each resistor. So we don't know the resistance of the resistor 1. We don't know the resistance of the resistor 2. So what we know here is basically that the equivalent resistance in series is 690 ohms, and the equivalent resistance in parallel is 150 ohms. Well, let's try now to write the equations of equivalent resistance for both cases. So know that the equivalent resistance in series is R1 plus R2. So if I do that, I can now say that if this equivalent resistance is 690 ohms, 690 ohms is equals to R sub 1 plus R sub 2. And here I got one first equation. I got one first equation. We say that in this case, R1 plus R2 is equal to 690 ohms. Now, let's do the same for this other resistor. So we know that 1 over the equivalent resistance in parallel would be 1 over the resistance of the resistor 1 plus the resistance of the resistor 2. So if we substitute the equivalent resistance in parallel by its value, we can say that 1 over 150 ohms will be equals to 1 over R sub 1 plus 1 over R sub 2. And here I have my second equation. So basically, what I have now is a system with two equations and two unknowns. And I will solve this system. I will try to solve this system. Okay? So what I'm going to do, right, try to solve, the system. Well, I will just try to transform a little bit my equation 2. So I will work on my equation 2 just to rewrite that equation 2 in a more friendly way. Okay. From now on, I'm not going to use the units, so I am not going to put the ohms anymore, to avoid any kind of confusion, between the symbol of ohm and any other letter or symbol that I can use. So I will work on my equation 2 to try to rewrite this equation in a more friendly way. Say, working on equation 2. Say my equation 2 is 1 over 150 is equals to 1 over r sub 1 plus 1 over r sub 2. Well, I know that the least common denominator here would be r sub 1 times r sub 2, the right part, right? So if I want to have both fractions with the same denominator, I have to multiply this first fraction by r sub 2, above and below, and 2, above and below, and I have to multiply this second fraction by r sub 1, above and below. So that means that now I get a 1 over 150 will be r sub 2 over r sub 1, r sub 2 plus r sub 1 over r sub 1, r sub 2. Of course, now I have two fractions with the same denominator, so we'll put them both together. And we just combine the fractions and we'll be adding the fractions. So I say 1 over 150 is equals to adding the fractions. I add the numerators and keep the denominator. So we say r1 plus r2 or r2 plus r1. It doesn't matter. So over r sub 1, r sub 2. Now I will just make it cross multiply. Okay. If I cross multiply, because I have like a proportion here, we say 1 times r1, r2 is equals to 150 times r sub 1 plus r sub 2. Right? And of course, 1 times r sub 1 times r sub 2 would be r sub 1 times r sub 2 equals to 150 times r sub 1 plus r sub 2. Okay? I will call this equation that I go here now equation 3. Well, now I will take my equation 1 and I will solve for r sub 2 in my equation 1. When I solve for r sub 2 my equation 1, I say my equation 1, is 690 plus, 690 is equal 690 equals r sub 1 plus r sub 2. If I solve for r sub 2, I get that 690 minus r sub 1 is equal to r sub 2. So now I have r sub 2 as a function of r sub 1. Well, I will substitute now my value or my expression of r sub 2 into equation 3. Substitute r sub 2 into equation 3. When I substitute r sub 2 into equation 3, we get r sub 1 times r sub 2. R sub 2 is 690 minus r sub 1. Let me erase this. 690 minus r sub 1 equals 150 times R sub 1 plus R sub 2, and R sub 2 is 690 minus R sub 1. I don't put the R sub 2 in parentheses because anyway, you know, the sign here is positive, so it's not going to change anything, in terms of the signs, or 690 minus R sub 1. So that's why I'm not going to be spending time in just putting those parentheses. So I will now say R sub 1 minus R sub 1 is 0. So I get that R sub 1 times 690 minus R sub 1 is equals 150 times 690. 150 times 690 would be 103,500. Of course, I apply now the distributive property here, and I say 690 R sub 1 minus R sub 1 times R sub 1 is R sub 1 squared is equals 103,500. Now what I have is basically now a quadratic equation. I will just rearrange the terms of my quadratic equation. So I will get it now. My equation becomes 0 equals R sub 1 squared minus 690 R sub 1 plus 103,500. And this is now a quadratic. And this is now a quadratic equation in a standard quadratic form. So once I have my quadratic equation in the standard quadratic form, right, I will now apply my, in this case, quadratic formula, for example. I can apply the quadratic formula. So when you apply the quadratic formula, you say, okay, let me, because of course you can try other method, but the easy one here would be the quadratic formula. So remember, I will just use the quadratic formula here below now. We say, okay, if I have that R sub 1 squared minus 690 R sub 1 plus 103,500 is equal to 0. Then when I use the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And we get that x is equals, and x is the same that R sub 1, of course, equals 2. Then negative, what is b? B is, in this case, minus 690, so negative 690 plus or minus the square root of b squared, which is negative 690 squared, minus 4 times 8, which is the coefficient of R sub 1, which is 1, R sub 1 squared, sorry, which is 1, times c, there is 1,300, sorry, 103,500, 103,500, all over, so just divided by 2 times 1. Well, you can find now the values of R sub 1, and you will get that R sub 1 will be now 469.6 ohms, which is going to be rounded to 470 ohms. Now, if you go now to the equation of R sub 2, where we have that 690 minus R sub 1 is R sub 2, you can say that 690 minus 470 is equal to R sub 2. So R sub 2 would be, in this case, 220 ohms. So there we have the values of R sub 1 and R sub 2. Approximately, right? I mean, in the formula, when you calculate, right, the values are decimal values, right? But we round, of course, and we get these values that are 470 ohms and 220 ohms. So those are, in this case, the values of R sub 1 and R sub 2. So it was a very interesting exercise, because in this exercise we had to use our knowledge of algebra. So we use how to add fractions with different denominators. We have used the distributive property, right? We use the quadratic formula, and of course we use, the solution of systems of linear equations